Sorry. So if you look in the review notes under one sample test of hypothesis, you will see which rule to use. So can you? Hi. Good morning. Yeah, we are question one. Question one. No? Guys, have you done question one yet? Let me show you if you haven't done it. Okay. So as I said, oh yeah, here. Hello, my friend. We are working on question one. Question one. All right, we are working on question number one, right? So let's see how we can do it. So in this case, question one. So we are trying to test in the first part, right? The first part, we are trying to test whether H0 is equal to, so the null hypothesis is where mu denotes the mean strength, mean breaking strength, right, of a cable, right, versus the alternative that mu is not equal to 200, okay? Now, what do you think is the rule that we need to use in this case? I mean, if you look in the review notes under one sample test, well, the first thing you need to figure out is whether the rule is different depending on whether the population variance is known or unknown. In this question, is the population variance known or unknown? Is it known or unknown? It's known. Yeah. So because you're told, okay, let's write down what is given to us. N, the sample size is 40. Sigma is the population standard deviation, which is given as 30. And X bar is the sample mean, which is, we are taking a sample of 40, right? So it's 1/40 times the sum of Xi, I from 1 to 40, which is, oh, you can't see me, which is equal to 8238.4 divided by 40, which if you work this out, this will be 208.21. So this is the sample mean, and we know the sigma equal to, sigma is the population standard deviation, and N is the sample size. So these are all that's given to us. These are the, so given this, the rejection rule, we reject H0 if you look at the review notes or the printed notes, either one, you will see the following. You will see X bar minus mu0, which is 20, divided by sigma by root of N is greater than set 1 minus alpha by 2. This is the rule for rejecting the null hypothesis, if you look at the notes, right? So let's work out let's work out the left-hand side, which is the absolute value of X bar, which is 208.21. Take away 200. Sigma is 30. Root of N is root of 40. Now, if you work this out, you will get this to be equal to 1.731. Right? And we are using alpha. There are two different values for alpha. One is, we're doing question 1. Let's take first alpha to be 0.05, right? If alpha is, so if alpha is 0.05, right, then the right-hand side, excuse me, can you see this? The right-hand side is at 0.975, which is 1.96, right? Whereas if alpha is, by the way, if you just come in, we are just doing question number 1, part 1, right? All right. If alpha is 0.01, then the right-hand side is at 0.995, which is equal to 2.576, right? So the conclusion, oh man, what did I do? Okay. So what do you see? The question is whether the inequality is satisfied or not. If alpha is 0.05, it is not set. I mean, 1.731 is not greater than 1.96. And if alpha is 0.01, still 1.731 is not greater than 2.576. So in this case, in either case, the conclusion is that in either case, oh yeah, just a minute now. We are doing question 1, okay? In either case, there's no evidence to reject the null hypothesis. This is how you will write. When you write a conclusion, you will say that if the rejection rule is not satisfied, then you will say there is no evidence against the null hypothesis that the mean breaking strength is equal to 200. Okay, that should be the conclusion. Okay, so that's part one. Part two is similar, so I'm not going to do part two. Part two is very similar, except the hypotheses are different. Right? So can you do question two, please? Can you move to question two? Oh, by the way, is this okay with you guys or no? Any questions on part one of question one? All right. No questions? You sure? Everybody okay? Yeah. All right. So let's go. Can you guys do now part? So we are done part question one. Can you do question two, please? Question two. I haven't done part two of question one because it's very similar to part one. Okay. So yeah, yes, yeah, 0.05. So 100 times 5% means 100 times 1 minus alpha is 5. Yeah. So 100. So 1 minus alpha is 0. No, no, no. No, sorry. It should be 5, man. 5. No.
Oh, and then you rearrange. No.
Yeah. Then you rearrange. Yeah. Yeah. You okay? Yeah. right, guys. Let me show you. If you haven't done it, let me show you how to do the three parts in question. Especially the last two parts, part 2 and 3 are different. So, excuse me. So the first part is similar to done. So the first part of question 2 is similar. So let's see. This question 2, part 1. We are trying to test whether the population mean is 0 versus the alternative mu is greater than 0. And let's write down what is given to us. We are told that x bar is 0. That the and we are told that alpha is 0.05. This is everything that's given to us. Okay. Now the question is, what's the rejection rule here? In this case, clearly the population variance is known. Okay. So what you need to use is the rule for rejecting this versus this. If you look up the notes, you will see the rejection rule is the following. If you look in either the review notes or the printed notes, you will see the rule for rejecting is x bar minus mu 0, which is mu sigma by root of n, is greater than z1 minus alpha. This is the rule for rejecting the null hypothesis. So if you look at the left-hand side of the rule, if you look at the left-hand side, which is x bar, which is 0.7, take away 0, sigma is root of 3, n is root of 10, and this works out to be equal to 1.275, right? And the right-hand side is that alpha is 0.05. Okay, so now if you read this off the table, this will be 1.645. So clearly 1.275 is not greater than 1.645. So the conclusion from this is, again, there is to reject the null hypothesis, right? Okay, guys, so that's part 1. This is very similar to question 1. Now, part 2, is this okay with everybody? Yeah? Right, part 2 is a little bit different, right? Part 2 is asking you to calculate the type 2 error probability when the true value is mu equal to 1 or if equal to 1.5, right? So let me turn the page, if you don't mind. So this is question 2, part 2. You remember last review session on Friday, the probability of type 2 error. Do you remember what it was? It's the probability of accepting the null hypothesis when H1 is true. Right? Do you remember this? Yeah, from Friday last week, I think I mentioned this. So this is the probability of accepting. Now, this is the rule for rejecting the null hypothesis, right? When so the probability for accepting will be the opposite of this rule, right? So instead of greater than, you will have less than or equal to, right? So you have, so this is the probability of x bar divided by sigma by root of n less than or equal to z or z1 minus alpha when mu is greater than 0. You follow me? Yeah? So this is the probability that you need to work out, right? Okay, so this will be, let's keep x bar as x bar. Sigma is, what was sigma? Sigma was 3, right? Square root of 3 divided by n was 10. Yeah. Less than or equal to z 0.95. Mu greater than 0. Right? Now the next step, I'm gonna use a trick which you should know from a long time ago, that when I talked about the normal distribution, one of the properties I mentioned in the we are doing question 2, part 2. Because remember, we are conditioning on the population mean being mu, not 0. It's not 0 anymore. All right. So what I'm going to do is the following. I'm going to because the population mean is no longer 0. It's mu. It's a positive number. We don't know what the number is, but we know, all we know is the positive number. Okay. All right. So I've subtracted the mu and added a mu. Now what I'm going to do is I'm going to take this part here. I'm going to take this part to the right-hand side of the inequality. You will see in a minute why I'm doing this. Right now, let me ask you, what do you know about the distribution of this? This is where the stuff that we learned a long time ago. I don't know whether you recall. Let me write down the property if you don't recall it. This is in the review notes, also in the printed notes. Do you recall this property? This is a property that I talked about when I mentioned about the normal distribution, right? Okay. So using this property, this guy here must have a standard normal distribution because of this property, right? Okay. So in the next step, I'm going to say this is n01 less than or equal to okay. Now as you can see, I removed the conditioning here because the conditioning is used to argue that this guy here has a standard normal distribution. So we don't need the conditioning anymore, right? We used it already. Okay. But if you like, you can leave the conditioning outside and say mu is greater than 0, right? Okay. So now this is phi at z 0.95 divided by mu divided by 3/10. Right? Okay, now in the question, in the actual question, is asking you to work out this probability when mu is 1 and also when mu is 1.5. So if you put mu equal to 1 and work out this probability, so this will come to 0.43 if mu is 1, and if mu is 1.5, it will come to Let me check. If mu is 1.5, this will be 0.14 if mu is 1.5. All right, so that completes part 2 of question 2. Is that okay or not? So you have to, like, I mean, the trick I've used in this part is to use the property that I think you will need to know. I think that's, if I'm not mistaken, you may need to know that for the exam too. The property that if you have a random sample from a normal with parameters mu and sigma squared, then x bar minus mu divided by sigma by root of n as the standard normal distribution. So that's the property I have used. It's a very critical property, right? All right, so that's part 2. Now part 3. Part 3 of question 2 is asking you, is asking you how large would the sample size be in order for H0 to be rejected in favor of H1. Okay, so to do part 3, you need to go back to this question here. You see, the rule for rejecting H0 is if this is greater than Z1 minus alpha, right? Okay, so in order to do part 3, let me show you. This is the solution for part 1. So question part 3. So it's basically asking you what should n be so that this rule is satisfied, this rule here, right? So in other words, we need to find n such that is greater than Z1 minus alpha, which is the same as saying that x bar is what? It was 0.7. Sigma is root of 3. Excuse me, still hiding. We don't know what n is. 5%, all right, so that's what we have. All right, so this is root of n times 0.7 outside divided by root 3. Greater than this guy here. If you read this off the table, this is 0.645, right? So this is the same as saying that root of n is greater than root 3 divided by 0.7 times 1.645, right? Okay, so in order to figure out what n is, you need to square both sides, so you get you need to do this, right? And if you work this out, 16.5675. This is what you will get, right? So because n must be an integer, this is same as saying that n is greater than or equal to 17, right? Because you can't have a decimal point for an integer value, right? So the smallest sample size so that the rejection rule is satisfied is 17, right? Is that okay, guys, or no? So this is, if you're wondering, what we are doing is question 2, part 3. Okay, guys, or no? All right, we are done with question 2 now. Can you go to the last question, please, which is question 7? Can you go to question 7, please? Question 7 of the exercise sheet. Can I take this away? All right. All right, so we are done with question 2, question 1. So can you look at question number 7, which is this one here? So question 7 is on portion. So you need to find the appropriate role for doing question number 7. Okay? So please do so. Right. Yeah, it's the same. It's the same. Yeah, it doesn't say, but 5% applies to part 2 and part 3 too.
So just we can use it.
Yeah, that's right. Yeah.
How to find in the
You just read like, you read like, for example, phi at 0 is 0.5.
Yeah.
So phi at 0.01 is 0.50, 40. So it's you just read the values along the first column, and then the horizontal column.
So for just like this question.
Yeah.
Therefore is
Point. No, you need to work this out. You need to work this out first, and then read it off the first column.
This is.
You need to compute that first.
This is for this.
Yeah, that's right. Yeah.
And phi day is probably.
Yeah, that's right. Yeah.
And this one
is 1.645, I think. It's
maybe 3.
Yeah, it's 0.5. Yeah, it's between these two, halfway between these two. So it's 1.645 minus. Yeah. Okay. Guys, can you do question 7, please? Question 7. Okay. Yeah. P0 is 0.1. Yeah. P0 is 0.1. But you need to find X bar is the sample proportion, so which is 47 divided by 400.
Yeah.
Yeah. Yeah. Okay. Yeah. So that's 0.1. So you're testing for P equal to 0.1 versus P not equal to 0.1. So you need to, do you know the rejection rule for this? You need to look it up in the notes. Do you have the review notes? You have to look it up in the notes. You guys okay? Okay. Guys, how far had you got? So let's see how we can do this question, guys. So this is question 7, part 1. So we are trying to test this hypothesis, all right, with the alternative by P to 0.1. Now, to us, we are told that we have 400 people, and X bar. Remember, whenever you're dealing with proportions, X bar denotes the sample proportion, right? What is X bar here? No? Is 47 divided by 400. All right, and we are trying to test at alpha is 0.05. All right, so this is everything that's given to us. Now, if you look in the review notes or the printed notes, you will see the rejection rule for this. The rejection rule reject H0 if minus P0 divided by, this is the rule. I mean, you will see. All right, do you see this rule? Hello, guys. Do you see this rule in the review notes or the printed notes? You should be able to see this. Yeah. So let's try to cut the left-hand side and the right-hand side of this rule. So the left-hand side is gonna be X bar is 47 divided by 400 minus 0.1 divided by n1 the 400. So if you work this out using your calculator, this will be 1.66667. Right, this is what you will get. All right, and the right hand side, RHS, is alpha. Remember, alpha is 0.05, so this is 0.975, so which is 1.96. Right? So clearly the left-hand side is not greater than the right-hand side. So the conclusion is that there is there's no evidence to reject H0. Okay? All right, are you guys okay with this? Yeah. So you need to find the appropriate role in the It's either in the review notes or the typed notes you can find in the course website, right? Okay, so that's part one. Part two of question 7 is asking you to calculate the approximate probability that you will correctly reject H0 when the true value is 0.103. Okay, so this is kind of stuff similar to what I did for question 1, right? So let me, can I turn to the next page, please? Okay. Question 7. So we want to find the probability of rejecting H0 when the true value is say 0.103. Okay. Now we know that from the stuff that we did, right? We reject H0 Okay, let me write down the whole thing again. X bar minus 0.1 divided by X bar. I don't want to put in the value for X bar. I will put it later. Right. This is the rule. This is the rule that I had written down earlier, right? Sorry, what is this? Visualizer is playing around. I don't know why. Sorry, excuse me. Don't know what the problem is. Okay, sorry. Okay, this is the rejection rule that I had earlier. Okay. All right. Now, what I'm going to do in the next step, I'm going to remove the absolute sign. Do you know how to remove the absolute sign when you have? How do you? I mean, you must have done this in your analysis or calculus courses. How do you remove an absolute sign? Like if you have something like say z greater than a, then how do you remove it? It's the same as saying that either z is greater than a or z is less than minus a. You know this, right? I'm sure you know this. Okay. All right, so that's what I'm going to do. So I'm going to write it like, please let me know if I run out of time. Somebody has time? Right? Okay. Or okay, like this. So you see what I've done? I have used the fact that if the absolute value of z is greater than a, then either z is greater than a or z is less than minus a, right? Okay, now these two events are mutually exclusive, and I'm sure you know from probability 1, if two events are mutually exclusive, then their union is the sum of the probabilities, right? Okay, so this. So I'm using the fact that the probability of the union of two mutually exclusive events is the sum of their probabilities. All right? Okay? All right, now in the next step, I'm gonna, because remember these two probabilities, we are conditioning on the true proportion being equal to 0.103, right? Okay, so the true proportion is no longer 0.1, it's 0.103, right? So what we need to do is we need to change these two guys here to 0.103, right? So that's what I'm gonna do in the next step. I know it's kind of long, but I hope you are patient with me. I'm gonna change this to this, right? And because of that, I need to add 0.03 to make it out, right? You see why I'm doing this, guys? Right? Are you okay with me? Are you following me? All right. Now I'm gonna change. I'm gonna take this guy here and this guy here to the right hand side. Right? So if you do that, are you getting tired? Do I have time? Can somebody watch how much time I have? 52 already. Oh, sorry. Run out of time. Sorry, guys. Can you watch the video? Like there's a video as everybody knows that there's a video giving the full solutions to all the questions on the course website. So can you please watch it? Now, what you need to do basically, just summarize in words. Take this to the right-hand side, take this to the right-hand side, and then use the fact that this guy and this guy has this approximate standard normal distribution, right? Use the fact that X bar use the fact this has an approximate standard normal distribution. This is a sign for approximation, right? To simplify the probability. Okay, guys, I'm sorry I ran out of time, but please watch the video giving all the solutions to all the questions, which is on the course website, right? As you know, right? And if you still have doubts, feel free to contact me 24/7. Okay. I hope you understood what I was talking about. Yes. No. Only you don't need to remember any of two sample will not come in the exam, sir. This is two sample, and on the.
What about the one sample? Do you need to remember these?
No, the only formulas you need to. Can you go to the course website? I'll show you. Can you go to the course website? The only formula you need to remember are the ones here, the ones in this sheet.
Okay. Will those be given to us in a question?
No, you need to remember that you can't take a copy of this to the exam. So you will need to remember all the formulas in